This video covers everything we did in math today on Wednesday, December 15th in 8th grade honors. Today's learning target is I can write equations of lines that have a positive or negative slope. Make sure you have ClassKick open so you can follow along. Your first step is to complete 11.1, which one doesn't belong, pairs of lines. There are 4 graphs in this picture, and your job is to determine which one doesn't belong and why. There's no right or wrong answer, but I'm looking for a full sentence in ClassKick. Please pause this video and complete slide 1 of ClassKick. Okay, you should have given slide 2 of ClassKick a try. And there's a few things you might have noticed. The first is you might have noticed that in graph A, we have a negative slope. Graph A has a negative slope, and that's something that's different from the other 2 graphs. You also might have noticed that in graph B, the lines are not parallel. And again, that's something that's different from the other graphs. You might have noticed that in graph C, the slopes equal 0, also different from the other graphs. The lines are not slanted. Or you might have noticed that in graph E, there is no y-intercept, meaning where it hits the y-axis at 10. The coordinate is 0, 10. And these are all things that set each of these 4 graphs apart that would have been acceptable answers to notice and wonder. Let's look at slide 3. 11.2 says, plot at least 10 points whose y-coordinate is -4. What do you notice? Then in question 2, it says which equation makes the most sense to represent all of the points with the y-coordinate of -4? Explain how you know. Please pause this video and complete slide 3, questions 1 and 2 in ClassKick. Your points with a y-coordinate of -4 could have looked something like this. They would simply move along in a horizontal fashion where the y-coordinate was -4. I'm going to make my marker thicker to make an easier dot. All of these points that I'm drawing on my graph have a y-coordinate of -4. And I can connect them into a straight line that's just a horizontal line running through y equals -4. Now, when it comes to an equation that would represent these points, my equation is simply y equals -4. The reason is because whatever the x value is, for example, if x is -4 versus if x is +2, does not affect the y. No matter what x is, y is always going to be -4. And so we don't even need an x in our equation. Take a look at questions 3 and 4. This is similar, except this time the x-coordinate is 3. Plot those points in question 3 and choose an equation in question 4. Please pause this video and complete questions 3 and 4 in ClassKick. So this time, our points are going to form a vertical pattern. Each of these pink dots I'm drawing have a y-coordinate, or an x-coordinate, I should say, of 3, and they have varying y-coordinates. And so once again, I can draw a line to connect the points. They're not perfect. I see some of them aren't exactly at x equals -3. But I can draw a line to connect the points, and that line represents a consistent x value of 3. And so this time, my equation will be x equals 3. Because again, the y-coordinate, whether y is 3, whether y is 0, whether y is -5, whatever the y-coordinate is, does not affect, it does not change what my x coordinate is. And so x is simply equal to 3. In questions 5 and 6, they've given you two equations. X is -2 and y is 5. Please pause this video and graph those two equations. Okay, let's take a look. If x is equal to -2, I would simply end up with a straight line through x is -2. And I made a mistake the way I drew that, because this would be y is -2, right? We got to be careful. X is -2, which means I'm going to have a vertical line, because every single coordinate pair that falls along this line needs to have a coordinate of -2. So this orange line that I just drew represents the equation x equals -2, because every single point that falls along the line has an x coordinate of -2. And then my second equation is y is 5. And so this time we'll have a horizontal line that simply runs through the y coordinate of 5. And every single point that falls along this line will have a y coordinate of 5. So y equals 5. Notice that when we have horizontal or vertical lines, our equations don't include the other coordinate. And what I mean by that is, when you have a horizontal line, your equation is simply y equals something. Because no matter what the x value is, the y value is the same. When you have a vertical equation, you simply have x equals something. Because no matter what the y is, x stays the same. In other words, when we're working with vertical and horizontal equations, y doesn't affect x, or x doesn't affect y. Let's take a look at slide 4. We're going to skip the Are You Ready for More portion, and I'm going to ask you to independently focus on 11.3 as your next activity. 11.3 says there are many possible rectangles whose perimeter is 50 units. Complete the table with lengths and widths of at least 10 such rectangles. I'm going to give you a couple examples to get you started. If we think of a rectangle, that's a terrible rectangle. Let me draw one slightly neater. If we think of a rectangle where the perimeter is going to be equal to 50, one set of side lengths I could have is 20, 20, 5, and 5. And so in this rectangle, the length would be 5 and the width would be 20. But I have the length twice, right? Because it's a rectangle, and I have the width twice. And so even though 5 and 20 add up to 25, the total perimeter, the distance around the shape, adds up to 50. Let's do one more example. I could have a really long, thin rectangle where the side lengths were 2 and 2, and then I have 46 units left, and so I would need to have 23 and 23. And so the width would be 23, and the length would be 2. Your job is to come up with 10 more combinations of lengths and widths. Well, I did 2 for you, so 8 more. 8 more combinations of lengths and widths that would create a perimeter of 50. Pause this video to complete 11.3 independently. Okay, so let's take a look at slide 5, and we'll use this table we just created. The graph shows one rectangle whose perimeter is 50 units. We can see a length of 15 and a width of 10, and has the lower left vertex at the origin and 2 sides on the axis. On the same graph, draw more rectangles with the perimeter of 50 units using the values from your table. Make sure each rectangle has a lower left vertex at the origin and 2 sides on the axis. Here's what that means. I'm going to come back to my table and say, okay, I can have a length of 5 and a width of 20. So on my graph, I would plot length 5, width 20. and I would have a point right there. Another one I had was a length of 2 and a width of 23. And so I can plot that point here as well. Once you're finished plotting these points, in question 3, they will ask you to draw the line and write an equation. And in question 4, they will ask you to find the slope. You are going to complete these tasks independently, and that's the last thing you need to do for classwork today, besides tonight's homework, which is posted in Schoology. So again, your next steps are to complete slide 5 independently, and then go to Schoology for tonight's homework. As always, if you have questions, please make sure to send me an email.